Hello everyone, welcome back to this video series on clinical SAS ADaM programming. So we are taking a look at some of the scenarios where new parameters are needed to be created. So as part of that, we will see how to create a new parameter to handle a second system of units. So we know that every collection we make, in most of the cases, we'll have an associated unit with it. Sometimes we will need to analyze the data in two different units. So in the case when the collected unit is available and if we want to report it in a different unit, what ADaM suggests is us to create a new set of records. So in this example, we will see a case wherein we had to report height in both centimeters and meters. So let us see the description. So we have the height of the subjects collected in centimeters. For our analysis purposes, let us assume that we need to report the height in meters as well. So we are creating a new set of rows with a different parameter name to store the converted values. So let us assume that these initial light yellow colored rows are the collected rows wherein the values are reported in terms of centimeters for the height of the subjects. Now we need the same height values to be reported in meters as well. So for that we are creating this new set of rows. On this new set of rows we are naming the parameter as height in meters. So in the new set of rows, we would transform the results collected and into meters. So if height is collected in centimeters, if you want to convert it into meters, so we need to divide the collected result divided by 100, and then if there is any rounding, we'll apply the rounding and then store the value here in meters on the rows of height in meters. So let us see the specification for this now. So we have the specification for ADT, param, param-cd and eval. So for ADT, it says derive this variable using VSDTC from SDTM vital signs dataset. So extract the date portion from VSDTC and then convert it into numeric value. And for param, it says for source parameters. So we have seen in the description that we have source parameter, which is the height in centimeters or height in centimeters reported is collected as is called as source parameters, and we are creating a new parameter called height in meters. So we have the definition for param is split into two sections, for source parameters and for derived parameters. So for source parameters, it says derive using VS test from vital signs and VS STRESU, which is vital signs standard result unit. So, and then second step says when VS test CD is height, then set param as VS test value concatenated with VS STRESU within parentheses. So we need to concatenate the units reported in parentheses to the value present in VS test variable for the source parameters. And then we have section B, which says create a derived parameter height in meters using the source parameter height in centimeters. So this is what we were discussing in the description. So we will be using the source parameter source height centimeter records and create a new set of records for height in meters. And then we have param CD. It says for the source parameter set to the value equivalent to the value present in VS test CD variable. And then for the derived parameter height in meters, so we are being asked to use a value height mt. So mt stands for meters here. So we are being asked to use this value in param CD variable for the new set of rows. And then for eval, again the definition is split into two sections. So for the source parameters, use the value from VSSTRESN variable. And for the derived parameter height in meters, so we know that we are creating it from the height in centimeter rows. So it says set the eval and height in meters row to eval divided by 100, where param CD is equal to height. So we'll have to use the eval values from the rows where param CD is equal to height and then divide that by 100, and the resulting value has to be stored as eval on the newly created rows. And then that the eval is being asked to be rounded to two decimals in this example. So we have now seen the specification for this task. We will now move to the programming. So here on the left hand side I have my program, and on the right hand side I have my input dataset as well as the intermediate datasets and the final output dataset. So here vital signs dataset is main input dataset for this example. We have it on the screen here. So we have height reported for 4 subjects here, and if you see here the height is reported in terms of centimeters. Now each of these values are have to be reported in meters as well, but instead of adding that as a variable, we are being asked to create a new parameter for height in meters. We will see that now. Again, some like in my previous videos, the code that creates this input data is present in a program called this L102 underscore data dot SAS. So I am including that program here in this program. So when this line of code gets executed, all the code present in that program gets executed, and my input dataset gets created in the work library for me. So here I am creating a temporary dataset called VS01 from VS, and another temporary dataset called DM01 for DM using DM dataset. But we'll not be using DM for this example, but I have just created a copy as I had it as input. So, and we are using VS01 as input and then creating a new dataset called VS02. So we are creating some of the variables which can be directly be derived based on the input variables. So here the first variable we are creating here is param_cd. So in VS01 what we have is actually the source parameter records. So for the source parameter records for param_cd, so we were asked to use the value from VS_test_cd. So we are assigning the values from VS_test_cd to the newly created variable called param_cd. And then for param, we were asked to concatenate the values present in VS test and then VS stresu, but concatenated within parentheses. So I am concatenating VS test values here with the values present in VS stresu with parentheses here. I am using pipe operators, a concatenation operator, to concatenate the values present in these variables. So param would be created. And then for ADT, so we were asked to extract the date portion from VSDTC and then convert it into numeric. So we know that in ISO 8601 notation, date time values are present in YY, 4 character year hyphen 2 character month hyphen 2 character day. If we have time, then we will have the T delimiter followed by hours, minutes, and seconds separated with a colon in between. So if we from VSDTC, if we are extracting the first 10 characters, they would correspond to the date component in date component. So we are extracting the date component using substr function here and then converting the resulting value to numeric using input function and yymmdd10.in format here. And then for eval, we were asked to create it as copy of vsstresn. So we are simply assigning vsstresn values to eval variable. And then for the newly created date variable, by default, the number returned would be seen as the number of days from 1st Jan 1960 in SAS. So we want to make it human readable. So we are associating a format called date9 to the ADT variable. And then we are creating a new dataset called VS03. In this step, we are appending VS02 dataset twice. So before we go into this code, let us take a quick look at our VS02 dataset to see how the newly created variables are looking. So here we have created param_cd. It is simply a copy of the values present in VS_test_cd. So it will be the same here. But for param, so we use two variables, VS_test and VS_stresu. So we concatenated this unit in parentheses to the value present in height variable. So it should look like height within the parentheses as centimeters. So this is coming correctly here. And for ADT, so we extracted the date component from VSDTC and then converted it into numeric format. So we have applied a format of date9 to it. In SAS, when we apply date9 format, the date would appear like this. The two 1 or 2 character for day and 3 character for month, and followed by 4 character year would appear. And then we have simply assigned the values from VSSTRESN to the eval variable, as these are the source records. So now we will make use of this dataset and create our new set of rows. So basically we need the same set of rows created or appended to this dataset again, but on that records we want the eval to be transformed by dividing it with 100. So we will do that in the next step here. So here we are doing that here when creating this VS03 dataset. So VS03 is being created by appending VS02 twice. So first instance, so we are temporarily identifying the records coming from this dataset using a temporary variable named A. And then in VS02 we are appending it twice. We are making sure that we are only subsetting the rows corresponding to height. In the example I have only taken the rows corresponding to height, but in any general vital signs dataset you will have other parameters like weight, systolic blood pressure, diastolic blood pressure, and so on. For the sake of simplicity of explaining this, I have used the source parameter as only height. So here we are subsetting only the records corresponding to height, and then we are making use of a temporary variable named b to identify the records coming from this second instance of VS02. So in the next step, what we are doing here is if a record is coming from this second instance of VS02, so we are checking if eval is greater than missing, then eval is equal to eval divided by 100. So what exactly we are doing here? So we are using the eval from this row, and then if it is greater than missing, so we are dividing this number 167.6 divided by 100 and then rounding it to two decimals. So in order to round it to two decimals, the syntax is to make use of round function, and the second argument has to be 0.01. If we have to round it to one decimal, we'll have to put it as 1, 0.01, zero 0.1. And if we have to round it to three decimals, the second argument would be 0.001. So we are now converting the source eval to meters by dividing it with 100 and then rounding it to 100, and then we are storing the number in eval variable itself. So we are applying transformation and storing the resulting value in the same named variable. So and then as per the specification on this new set of records which are being created for height in meters, so we were asked to use the text height empty in param_cd variable. So we are assigning that here. And then for param, we were asked to use the value of height separated by space and within parentheses, as we are reporting it in meters. So we are using the abbreviation for meters as m here. So now this completes the derivation for or adding the new records for height in meters. So let us now see how our VS03 looks like. So we will get all the rows from VS02 and all the height rows get obtained from VS02, and then on this new set of rows the eval is transformed and the param_cd would be height empty and height in meters. So let us take a look at VS03. So here if we see, we have four records which are directly coming from the first instance of VS02. These are the four records which are coming from the second instance of VS02. But on this record, so what we have done, we have set the param_cd to height empty and then param as height in meters. But we have also transformed the eval on this record as 167.60 divided by 100 and then rounded it to two decimals. So it is 1.68. Similarly, we have processed for all the other rows. So this is how you can create new set of rows in order to handle a second system of unit. Finally, let us take a look at the output dataset. So wherein I have logically ordered some of the derived variables and kept only the derived variables. Let us take a look at the output dataset before we close. So here, this is how your final ADaM dataset would look like for the newly created rows. So for the derived variables, so we have source records, we have derived records, and in terms of a derived parameter to handle a second system of unit. So the same example could be replicated for any scenarios. So though we might have taken here a simple example of converting centimeters to meters. Thank you for watching and keep learning.